So we're looking at solution of a quadratic equation. Now there's a general form for writing quadratic equation. It's ax squared plus bx plus c, and it must be equal to 0. Now a cannot be equal to 0, and a, b, and c, these are members of real numbers. They are members of real numbers. In other words, it could be fractions, it could be decimals, it could be whole numbers, natural numbers, integers, all type of numbers, a, b, and c. However, again, a cannot be equal to 0, however, and a, b, and c, they're members of real numbers. The x, however, is an independent variable. Now, a is the coefficient of x squared, b is the coefficient of x, and c is just a constant term, just a number by itself. Now, there are three algebraic methods that we'll be looking at: factorization, formula, and completing the square, all methods of solution to a quadratic equation. Now, for factorization, if the product of m and n, that is m times n, equals 0, where m and n are numbers, members of real numbers. When you multiply two numbers and you get 0, it indicates that one of them must be equal to 0. Isn't that so? Either the m is 0 or the n is 0. Or it could be both equal 0. For example, 0 times 0 equal 0. So m and n could be equal to, both could be equal to 0, or one of them is 0. Now, if the product of two factors equals 0, then one or both factors equal to 0, as I mentioned before. Now, when we factorize a quadratic expression, what do we usually get? We usually get the product of two binomial expressions. Let's call them m and n. Alright, but we know what binomials are, right? Two terms in a bracket, multiplied by two other terms in a bracket. But we're taking those binomials as m for one and n for the other as factors. So for a quadratic equation, this product must always be written equal to 0. For an expression, it's just binomial times another binomial. For an equation, unlike an expression, it must be equal to 0. Those two factors must be equal to 0. Now, since both factors are equal to 0, or either one is 0, these facts allow us to solve quadratic equation using the method called factorization. Sorry about this. This is factor, an R here. Okay, so what we're going to do now, we're going to solve this quadratic equation. We can do that through three methods, as mentioned before. We're looking at factorization, however, to solve quadratic equations. We multiply the first term, which is the ax squared term, by the last term, which is the c term, the constant term. And that will give us, let's look at some side work, negative 30x squared. The two factors that will actually give us negative 30x squared will multiply it, and it will give us as a sum negative 1, will be negative 6 and positive 5. Or 5 and 6 will give us 30. If we look at negative 6x and positive 5x, when you multiply them, you get negative 30x squared. When you add them, you get negative 1x, which is the middle term. So we're splitting this middle term into these two terms. So write back this 2x squared, split this middle term into two parts, which is going to be 5x and negative 6x. Write back that negative 15 equals 0. You should notice that this equation is the same as this equation. Why? Because we're separating this term into two parts, which actually has the same value. Now we'll be able to factorize this now. This part of it will be x as a common factor in both of these two terms. X times 2x will give us back 2x squared. X times 5 will give us back 5x. X times 2x, 2x squared, x times 5, 5x. We write back the same thing here. The 2x plus the 5 What term will we put here to give us back these two on top? Well, 3 2s is 6, so we put 3. And we want negative. This is positive, so we make this negative. Unlike signs, multiply give us negative. So negative 3 times 2x gives us negative 6x. Negative 3 times 5 gives us negative 15. Now we need to factorize this part and this part. What's common in these two parts? As you can see, it's going to be 2x plus 5. And 2x 5 times x will give us 2x plus 5 times x. And 2x plus 5 times negative 3 will give us back this part. Okay? So now we have factorized the expression part of the equation, which is 2x plus 5 times x minus 3. You have to keep putting back the 0. Now if these two factors, okay, this is one factor and this is another factor. When you multiply them, you get 0. That means one of these factors must be equal to 0. So if this is 0, multiply by this factor, you'll get 0. If this factor is 0, when you multiply it by this one, you'll get 0. So one of them is 0. So when you multiply them, you get 0. Or both of them could be 0. 0 times 0 give us 0. So we're going to write either the 2x plus 5 equals 0, and then we're going to solve for x. Subtract 5 on both sides. Okay? And then we're going to get 2x equal negative 5. Then divide both sides by 2, so we can get x. We're going to get negative 5 over 2. And that is going to be the first part of the solution. Okay? The next part is x minus 3. As we say, this could also be what is equal to 0. X minus 3 equals 0. We're going to add 3 to both sides to get rid of this negative 3. And we're going to have x equal 3. So we added 3 to both sides. So that's the second part of the solution. So this binomial times this binomial give us 0. So one of these binomial must be equal to 0. Or both being equal to 0. That when you multiply them, you get 0. We did just that. This one equals 0, and we solve for x. We set this one equal to 0, and we solve for x. So we have two solutions for x. Okay? Usually, for quadratic expressions, we have two solutions. We could also have one solution. We'll look at that in other examples. So the two solutions for x, we can represent in a solution set. You don't have to do this unless you're required to ask to, but these are the two solutions. But this is an option of how you can represent it. This read x is equal to the set of negative 5 over 2 and 3. Okay, x is equal to, this means the set of this bracket, set of negative 5 over 2 and 3. Now let's look at this equation, quadratic. In order to solve it, what would we have to do first? Well, first you have to recognize that it's not equal to 0. So we need to ensure that it's equal to 0 in order for us to find a solution by factorization. Okay, so what we're going to do? Well, what we can do, we subtract this 14x. It's positive 14x, so in order to get rid of it, we need to use negative 14x. In other words, to subtract it. Subtracting 14x on this side will give us 0 on this side, and we'll have, so we just subtracted 14x from both sides. And so we subtract 14x from this side, we have 15x squared minus 14x minus 8. Ensuring this is in the proper order, the quadratic term, the linear term, and the constant term. Good. Once it's in the standard form, we can now factorize. First times the last. Let's check that. That will give us 8 times 15, that will be 120. They're unlike signs, and so that will give us negative 120. Alright, we need to find the factors or the factors of 120, the pair factors that will give us negative 14x as a sum when we add them. Let's check that out. Now we know that 1 and 20 cannot work, definitely. 1 and 120 can't work. Let's try, well, we know what 2 and 60 can't work. We know that 3 and 40 can't work. We know that 4 and 30 can't work. All of these, when you multiply them, will give us 120. Let's continue quickly. We say 5. Now 5 into 12 goes 2 times. Remain 5 into 20. 5 goes 5. Goes 4 times. Okay. 5 and 12 goes 2 times. Remain the 2. 5 and 20 goes 4 times. Multiplying these give us 120, but the difference between these cannot give us 14. So let's continue. Let's try 6. 6 times 6 into 12 goes 2 times, so that's 20. Yes, this looks like it can work. So all of these would not work, but this one will. 6 times 20 give us 120, and if we subtract, find the difference between, we can get 14. So we're going to give the bigger number the sign of the middle term, which is going to be the negative 20, and this one will give positive. So multiplying these two will give us negative 120, and adding them will give us negative 14. It's negative 20, you add 6 to it, you get negative 14. So you're going to be positive 6x and negative 20x. Multiply give us the x squared, and add give us the x. Okay, so we're going to write back this 15x squared and plus 6x minus 20x minus 8 equals 0. Doesn't matter which one you put first, remember that. The solution will be the same in the end. Factorize in groups. So what's the common factor here? Between the numbers is 3 and x. And so we're going to say 3x times what give us 15x squared, it must be 5 to give us 15, and x to give us x squared. 3x times that will give us 6x, 2, that will give us 6x. Write it back over here, 5x plus 2. What number will we multiply by 5x to give us negative 20? Well, it must be 4 first of all, to give us 20. And it's negative, so this is positive, so this must be negative, unlike, to give us negative. Negative 4 times 5x, give us this one. Negative 4 times positive 2, unlike, give us negative 4. So that works. Okay, factorize this part of the expression with this part of the expression. So what's common is 5x plus 2. 5x plus 2 multiplied by 3x will give us this part. 5x plus 2 multiplied by the negative 4 will give us this part. Okay? And so those are the two binomial factors to this equation. Right, we need to solve for x. So either this is equal to 0, or this is equal to 0, or both equal 0. So we're going to put either 5x plus 2 equals 0. Then we solve, subtracting 2 from both sides will give us, dividing both sides by 5. We're dividing because 5 is multiplying. So divide to get rid of it. Give us 1x. Divide by 5. And so we have the first solution for x. Now the next one is 3x minus 4. To get rid of this, we need to add 4. It will cancel. So we're going to add 4 to both sides. And then to get rid of this 3, it's multiplying x, so we divide by it, both sides, that is, we have x equal to 4 over 3. And of course, if you feel more comfortable, you can put it as 1 and 1/3. So that will be the second solution. Alright, so the two solutions we have there. is that x is equal to the set of negative 2/5 and 4/3. Okay, now grab a pen and ensure you write these down. You're going to factorize this on your own, and then afterwards I'm going to